Hello everyone, I'm Manishi Singh from Kendra Vidyalaya 39 GTC Varanasi, and today I'm going to take up one topic from the lesson Structure of Atom, and that is order of filling of electrons in an atom, filling of orbitals or filling of electrons in orbitals in an atom. Before that, I would like to just recall what we have already done, that there are 4 quantum numbers which describe the location of an electron. They are just like an address of an electron, and the 4 quantum numbers are: the first one, the principal quantum number, whose value is equal to 1, 2, 3. N equals 1, 2, 3. It can be anything greater than 1. So this principal quantum number gives an idea about the size and also the energy of the orbital. The second quantum number is the angular momentum quantum number, which is denoted by L, and its value ranges from 0 to n minus 1. And this quantum number, it defines the 3-dimensional shape of the orbital. The third quantum number is the magnetic quantum number, and it gives information about the orientation of the orbitals in the atom. Now its value ranges from minus L through 0 to plus L. The fourth quantum number is the spin quantum number. The fourth quantum number is the spin quantum number because an electron, when it is moving around its own axis, it is also revolving around the nucleus. It is moving on its own axis as well as moving around the nucleus. So, as per the spin quantum number, an electron can have 2 orientations. That is, it can have 2 spin states. One is spin up and the other is spin down. That is plus half or minus half also we can say. So, one is moving clockwise and the other is moving anti-clockwise. So, in an now how to follow the filling of electrons. There are certain rules laid down which we have to follow while filling the electrons in an orbital. Now the first rule is the Aufbau's principle. Aufbau's principle, it states that when the electrons are being filled in the orbital with the lowest energy is filled first, and then the electrons are filled in the orbitals with higher energy. So the filling of orbitals is in order of their increasing energies. Filling of orbitals is in order of their increasing energies. So we can say that when an electron enters an atom, the first orbital is 1s. Electron will enter 1s orbital, then it will come to 2s, then 2p, then 3s, and then 3p, and after 3p it goes to 4s. After 3p it goes to 4s. After 3p the electron is going to 4s because energy of 4s is less than the energy of 3d. So this is how, if we follow this chart, then the configuration will not be wrong. Filling of electrons will take place in this order only. And after Aufbau's principle, we have the Pauli's exclusion principle. Pauli's exclusion principle, this states that no 2 electrons in an atom can have all the 4 quantum numbers same. Even if the 3 quantum numbers are same, the first, second and third quantum numbers are same, the fourth quantum number has to be different, because no 2 electrons will have all the 4 quantum numbers same according to Pauli's exclusion principle. Or you can say only 2 electrons may exist in the same orbital. Only 2 electrons can exist in the same orbital, and these electrons must have opposite spin. Even if the orbital is same, the spin of the electrons has to be different, or in other words we can say that the spin quantum number has to be different. So the maximum number of electrons in the shell with the principal quantum number n is equal to 2n square. That is maximum number of electron in any shell with the principal quantum number n is equal to 2n square. So we can find out the total number of electrons present in any principal quantum number. Now the third rule is Hund's rule of maximum multiplicity. Now according to this rule, Hund's rule states that an electron, when it enters an orbital which has 3 orientations, suppose p orbital, when the electron is entering a p orbital, it has 3 orientations, px, py and pz. First, electrons will enter singly in the 3 orbitals, and once each orbital has one electron, then pairing will start. Pairing will not start, 2 electrons will not enter the same orbital. Once px, py and pz, all the 3 orbitals, they have one electron, then only pairing starts. This is known as Hund's rule of maximum multiplicity. Now coming to the electronic configuration of atoms. Now the distribution of electrons in the orbitals of an atom is actually electronic configuration. How the electrons are distributed in the orbitals, how the electrons are arranged in the orbitals is known as electronic configuration. Now we know that there are principal quantum number, principal energy levels 1, 2, 3, 4. Then we have the orbitals sp, df. Then they have different orientations. S has only one orientation, p can have 3, and d has 5 orientations. So how to fill these electrons? When an electron approaches the first principal energy level, for example in the atom of hydrogen, there is only one s orbital. So electron will enter this 1s orbital only. In the second element, helium, which also has only 1s orbital, the second electron can enter the same orbital because 1s can have a maximum of 2 electrons. There is only 1 electron, so the pairing can take place and the configuration will be 1s2. In case of lithium, the configuration is 3. So first the electron will go in the 1s orbital and the pairing will take place. So 1s is complete, we write as 1s2, and after this 1s2 we have 2s orbital, and the electron can now go in the 2s orbital, and the configuration then will be 1s2, 2s1. In case of beryllium, who has a total number of 4 electron, beryllium, it has 2 electrons in the 1s orbital and 2 electrons in the 2s orbital. So the configuration here is 1s2, 2s2. Similarly for boron, now the 2s orbitals are complete. Now the electron will enter the 2p orbital. After 2s we have 2p orbital, and p orbitals have 3 orientations, px, py and pz. So the electron will enter in the first orbital. So in case of boron, the configuration will be 1s2, 2s2 and 2p1. 1s2, 2s2 and 2p1. Like this we can fill the p orbital with when we talk about carbon, the next electron will enter the second p orbital, and in nitrogen the third p orbital, and in oxygen then pairing will start. This is according to Hund's rule. One electron is present in the 3 orbitals, and now pairing can take place. So now we have, with oxygen we have one set of paired electrons, then with fluorine we have 2 sets, and in case of neon it is completely filled. 6 electrons are present in the 2p orbital. For neon the configuration is 1s2, 2s2 and 2p6. P can have a maximum of 6 electrons, and 6 electrons are present. So this is how we will write the electronic configuration of these elements. Now the electrons which are present in the outermost shell are the valence electrons. The electrons which are present in the outermost shell are the valence electrons, because these are present in the outermost, and these electrons are added to the electronic shell with the highest principal quantum number, so they are known as valence electrons, and these only take part in chemical reactions. And those electrons which are present inner to the valence shell, they have completely filled shells, they are known as core electrons, and they don't take part in reactions. Only the outer electrons will take part in chemical reactions. Now if you have d orbital, d can have a maximum of 10 electrons. D can have a maximum of 10 electrons. There are 5 shells, and d can have 1 electron. For d5 configuration, like in case of chromium, the configuration is 3d5 4s1. Now here d orbital has 5 electrons. Now having 5 electrons means it is half filled. Whenever there is half filled configuration, it gives extra stability to the atom because of the symmetry. Because of symmetry, these half filled orbitals are extra stable. Similarly for copper, copper has a configuration of 3d10 and 4s1. 3d10 and 4s1. This is 3d5 and 4s1. Now in copper, all the 5 orbitals have 2 electrons. So it is, total number of electrons are 10. So it is completely filled. Now a completely filled orbital is extra stable. Half filled and completely filled orbitals are extra stable because of symmetry. So copper 3d10 4s1, this configuration we say it is extra stable, and for chromium the configuration is 3d5 4s1, this is also extra stable. Now in case of inert gases, the configuration is the octet is complete. It is complete. The configuration of all the orbitals which are there is complete. So these are known as inert gases because they don't have any unfilled or incompletely filled orbitals. So they don't take part in reactions because they are completely filled. Now reaction will take place only if there are incomplete orbitals. If there are incomplete orbitals, then only it will take part in chemical reaction. If it is completely filled, it will not take part in chemical reaction. We say it is extra stable. So this is about filling of orbitals. Filling of orbitals in elements starting from hydrogen. Thank you.